Have you ever wondered how you make Salesforce talk to the outside world? How do you pull in data from other systems or push updates out to them in real time? Well, that's exactly what we're going to dive into today with one of the most powerful features in Salesforce development, Apex Callouts.
First up, we'll break down the fundamentals of what a callout even is. Then, we'll get into the super important security setup. Seriously, this is something you have to get right. From there, we'll get our hands dirty with some code, looking at GET and POST requests. We'll also cover how to handle responses and, the inevitable errors that happen in the real world. And finally, we'll wrap up with the best practices and limits that'll really turn you from a novice into a pro.
All right, so let's kick things off with the big picture. What exactly are we talking about here?
At the heart of pretty much every integration project is this one fundamental question. How do we build those bridges that let data flow freely and, most importantly, securely between our Salesforce org and the rest of the universe of apps out there? And the answer is an Apex callout. This diagram here really simplifies the whole thing. Your Apex code inside Salesforce bundles up a request, sends it securely over the internet to some external web service, and then it listens for that service to send a response back. It's really just a simple but powerful conversation between two systems.
So, to put a slightly more formal definition on it, an Apex callout is just your code making a standard web request, what we call an HTTP request, to an external API. It's the key that unlocks a whole world of external data and functionality for your Salesforce org.
But, and this is a big but, before you write a single line of code, there is something you absolutely have to get right. And that's security. This part is non-negotiable. And this brings us to the number one rule, the golden rule, whatever you want to call it. You never, ever, ever put passwords, API keys, or any other kind of secret directly into your Apex code. It's incredibly insecure, it's a nightmare to manage, and thankfully, it's completely unnecessary.
So what's the solution? It's something called a named credential. The best way to think about this is like a secure vault, or maybe a passport for your code. You tell Salesforce the address of the external system and all the login details just one time, and Salesforce handles the rest. Your code never even needs to know the secrets.
And here's a little peek at where this all happens in Salesforce setup. You can see we define the endpoint URL and the authentication protocol right here. By doing it this way, you completely separate your configuration from your code, which is just a huge win for security and makes your life so much easier down the road.
And you want to know the best part? Look at how ridiculously simple this makes your code. You just use this special callout prefix, followed by the name of the credential you set up. That's it. Salesforce sees that, knows to go look up all the secure details, and handles the entire connection for you. It's clean, it's simple, and it's secure. Okay, so we've got our secure foundation locked in. Now let's get to the fun part, the code. Let's actually see how we make these callouts happen. Now, the two most common types of requests you're going to make are GET and POST. Honestly, the difference is super easy to remember. You use GET to, get or read data from another system, and you use POST when you want to post or send new data to that system. Simple as that. Making a GET request is like following a simple recipe you'll use over and over again. First, you create the request object. Second, you tell it where to go using your named credential. Third, you set the method to GET. Fourth, you send it. And fifth, you process whatever comes back. It's a really straightforward, repeatable process.
And here's what that recipe looks like in a real piece of code. This is a complete, working example. But look closely at what's not there. No usernames, no passwords, no secret API keys floating around. Just that clean, simple reference to our named credential. That's how modern secure Apex is written.
Okay, so what about a POST request? Well, it's almost identical to a GET, but with one crucial extra step. See that line that says set body? That's the key difference. That's where you package up the data you want to send, like a new order in this case, and attach it to your request. It's that easy. This diagram is awesome because it shows you the entire journey from start to finish. It all kicks off with a user clicking something in their browser, which calls our Apex code. Our code then makes the call out to the remote system, which does its thing and sends a response all the way back. It really helps you see how all the pieces fit together. But what happens when things don't go perfectly? Because let's be real, in the real world, networks fail, systems go down, and not every single request is going to be a success. So let's talk about how to write robust, professional code that doesn't just fall over when something unexpected happens.
Whenever an external system responds, it sends back something called a status code. It's like a little signal telling you how things went. If you see a 200 or 201, you're golden. Everything worked perfectly. But you have to be ready for codes like 400, which basically means you sent me bad data, or 500, which means something broke on my end. Your code has to be smart enough to handle all these different outcomes. And you know what? Even before you check that status code, your entire callout needs to be wrapped in what's called a try-catch block. This is your safety net. It's non-negotiable. If the network is completely down or the other server just doesn't respond at all, this block is what will catch that error and prevent your whole program from crashing.
All right, to wrap things up, let's go over a few key rules and best practices. These are the kinds of things that'll really separate you from the beginners and take your skills to the next level.
Okay, listen up, because this is probably the #1 mistake, the #1 gotcha that trips up new developers. Salesforce will not let you make a callout directly from a database trigger. Why? Because that callout could take a long time, and you can't hold up the database. The solution is always to use asynchronous apex like a queuable.
And here's a number I want you to burn into your memory: 100. That's it, 100. That's the absolute maximum number of callouts you can make in a single, synchronous transaction. This is a hard and fast governor limit from Salesforce, and you have to design your solutions around it.
Okay, so let's boil all of this down into your interview cheat sheet. If you're ever asked about Apex callouts, these are the 6 things you need to nail. Number 1, always use named credentials. Number 2, know that get fetches, post creates. 3, remember callouts are forbidden in synchronous triggers. 4, know that queuable Apex is your friend for async callouts. 5, always handle your exceptions and status codes. And 6, be mindful of that 100 callout limit. That's the core of it all.
So, we've covered the why, the what, and the how of Apex callouts. The only piece missing is you actually getting out there and building something. With this power to connect Salesforce to pretty much any service on the internet, the possibilities are literally endless. So my final question to you is, what are you going to build first? What problem are you going to solve? The world is waiting.